Hello everybody. Last time we saw what was streams. Okay, for streams, I told you about things like how you have a stream head and a stream head, and then you have push. You can push modules and pop out modules, and you can do all the kinds of different kinds of configurations of the streams. It's like Unix pipeline. Okay, so you can use Unix pipeline. The same kind of thing is there. It's all done in script. Okay, script batch files are kept where Unix operating system uses those scripts batch files, and if it wants to do something, it can just plug in those scripts wherever it wants, and it can include any kind of module within the streams module. Okay, now today we are going to talk about something about dynamic link libraries. Dynamic link libraries are libraries which are like script libraries. Okay, there are different kinds of libraries. Okay, one is libraries which are written while running on the things, while running the system is running, and then you can just link all those things on the fly, on the run, and those are called dynamic link libraries. Okay, libraries are just like, like you can have those libraries in terms of JavaScripts, like scripts, script libraries, and different kinds of libraries, Visual Basic libraries, then script libraries, and those kind of things. Okay, you can have it in a script form, or you can have it as a module kind of form. Real time kind of libraries are like dot to object files kind of thing. It's all bit form. So you can just call that libraries. Mostly operating systems call those libraries for usage. Okay, those are dynamically linked, and those is called dynamic link libraries. Okay, because the real time operation while it is running, you can't convert them into bit form and then use it. Okay, so that is why. So script libraries are a little bit different because they wait for some time and then you can dynamically have to link those things. Okay, so this is a basic thing difference, but there are things which can they have a link to dynamic link library straight away from the script. Okay, so you can run them on real-time systems also, some of the things. Okay, these are useful for scripting. While scripting, if you want to do an algorithm or something like that, and you want to push in some algorithms or take out some algorithms while on the run and things like that, these are called real-time artificial intelligence. Artificial intelligence are different kinds of things. Okay, where if a machine, ordinary machine can learn things, you have to write algorithms and just learn it. Okay, that is one kind of machine learning kind of architecture. There's another kind of data where dynamic link libraries are used, or the real-time systems are used, and those kind of real-time parallelism is called. Now we have to know streams parallelism. Parallelism is a kind of different kinds of parallelism are there. Okay, first thing, if you want to do a work or something, like if you have a project or something like building a house or something like that, then there are parallel things you can handle. Okay, one is you can plan for planning. You can use the thing. Okay, and for raw materials you can use the same time for getting the raw materials, and for the same time you can use it for making the bricks. Okay, you can the same time you can, so those things which can be done in parallelly, and finally the construction is done, which don't require any kind of bottleneck is like when one is dependent, when the time dependency is there. Okay, when synchronization of time, or modulation is required, those kind of things, like whether it's for planning, or it is for development, or for design, or for other kinds of things, they are used. Okay, but we are not going to design, development, all those things, but that is how the projects usually get done. But we are into artificial intelligence, and that form of learning. Okay, it's a kind of like algorithms on the run, real time algorithms on the run. You're creating algorithms and you're just plugging in those algorithms and see. Like for fuzzy logic and all, things are new kinds of algorithms come into play. Okay, these kinds of all dynamic link libraries. The real time system, they just produce new kind of algorithms which you don't even have realized, or kind of like you don't even know. So this kind of learning of new methods using fuzzy logic and dynamic link libraries and other things, those are called dynamic artificial intelligence. What is dynamic artificial intelligence? Okay, let's check in some of the things. It is just time dependent. Okay, say you give a robot to do some work, it is going to do some work. Okay, it is just going to use the intelligence and the algorithms are there. It is just going to dump those algorithms. It is going to find the shortest path and things like that, and it is going to do the work. Okay, now what happens if you want to dynamically change the control of the control of the robot. Say, sometimes the robot is learning some other things in English, and you want to suddenly switch it to, kind of French. Okay, the robot is not going to know. The artificial intelligence is not going to know learn all those things. It has to learn all the things, rewind again. And if you want to dynamically convert the robot completely English speaking robot into totally kind of like French speaking robot or a German speaking robot, the dynamic link libraries are used. Okay, the streams methods are used. Streams modules on the run you can have, like you have a stepney tire for a wheel. So you just fix the stepney tire and you just start the run. You just leave the kind of roller kind of thing, which helps you to drive for some time. And after that, or while on the running itself, you can just take out some of the parts and fix the parts, and then leave the thing back again. Something like checkpointing and other things. Okay, checkpointing is a kind of total stopover and things like that. But on the run, you don't have a stopover. Like some of the systems might crash and other things. So these dynamic link libraries, they use those dynamic link libraries and just do all the things. Okay, error correction is a kind of thing like if you have an operating system right now running, okay, you just create random error anywhere in the operating system, it should fail. Okay, if it fails anywhere like bit error, byte error, anywhere address error, everything, the operating shouldn't. This is called a stable operating system, because what happens is even if some part of the dynamic library fails or some part of the operating system fails, it is able to recover. Recover doesn't take all, it is just happening on the run. So if it just switches over to another model, if there's a crash kind of situation, it just jumps over and kind of like gives you a trap kind of thing, and then after that, the other kind of things take over and the error is corrected and new libraries are installed immediately. Those kind of things. Okay, the error is immediately identified. Okay, so you prove in an operating system while running, you can just introduce the error anywhere. Okay, anywhere, whether it is start beginning of the operating system, start of the operating system, end of the operating memory corruptions, stack corruption, that corruption, this corruption, everywhere you can introduce all kinds of error. And if the operating system is still running, then it means that it has got a dynamic link libraries and it is able to recover all these errors and dynamically able to adjust and learn new things. Okay, the failure point is almost zero. It's able to keep some of the things as backup and those kind of things. Okay, the same similar concept is there in artificial intelligence also. Dynamically, you have to learn new things in kind of project. Okay, sometimes you are running a project. Okay, and suddenly you don't have water or something like that. What do you do for that kind of project? Then you have to dynamically link another kind of thing which will give you the water kind of thing, or you can have a different kinds of solution for the same thing. Instead of using ordinary water, you can use salt water for a particular project or something like that. Those are all dynamically done on the fly and the fly. I told you already about streams. Streams is the kind of thing which can be used. Okay, they can just plug in right in the middle, and you can take it out, and then we have plug in some other module right at the floor, right on the. So sometimes the stream head may coming into existence, and sometimes stream head just vanishes. Some of the streams are removed, some of the streams are plugged in, some of the new streams come in, new streams plug in. These are dynamic complex learning procedures. Okay, these are dynamically complex learning procedures, because you cannot use the same kind of situation everywhere. Okay, learn for a machine learning or something like a chess game or something like that. You can have a fixed database kind of thing, or like tic-tac-toe or something like that. You can have a fixed database and you just dump the thing, and you know what is happening and things like that. Immediately play the game and win the game and things like that. That is for constraint oriented kind of learning kind of thing, objective kind of thing. But if you want to learn dynamically all the things, new things are coming up, and you want to know all these things, those kind of things are done by artificial intelligence, which are dynamic or real-time operating system. Real-time operating system equivalent. This is called real-time artificial intelligence. Okay, real-time artificial intelligence is a bit different from ordinary Ordinary artificial intelligence or natural intelligence is a kind of thing which is already stored database on certain fixed procedures, fixed data algorithms and things like that. And certain times they use fuzzy logic to arrive at certain conclusions and things like that. Okay, but dynamic, you design new algorithms on the fly, and then you just get rid of those algorithms and suddenly come up with new algorithms to kind of different kinds of situations. This is where dynamic thing is needed. Okay, say you have a storm or something, like you're going to predict the storm, and suddenly there is sun coming as a new factor. Then you don't know what is going to happen in the future. Within 10 minutes, say you're traveling in deep space or something like that, within 10 minutes there's a new kind of asteroid coming in. What do you do? So those kind of new things that are learned, those kind of things are dynamically happening, and for that you have to design a new kind of algorithm to get out of that situation, and then come out of the situation, and then keep running your artificial intelligence. Okay, the algorithms are like standard algorithms which go. Okay, those are all minimal algorithms. Then after that, learning algorithms are there, which are kind of learned because of experiences and other things, because of sensors, experience, motor experience. But are new kind of things which are coming in dynamically, and they just remove some of the old kind of forms, and creating new kind of algorithms. These are the kinds of things which artificial. These are the kind of things which is called real time artificial intelligence. Dynamic link libraries are basically like an operating system which is running. Those kind of things are used which dynamically link on the run, and then some of them fade, some of them come into existence, and some of them new kinds of things. But part of it is already stored, so you don't have to worry. And if the same kind of situation comes in, then you can use those kind of dynamic link libraries. So streams is a kind of things which allows for all these things. Say you're giving a subtitling on something like that, and after 3 minutes you come into a new kind of situation where you don't want subtitling and you want to do the color change. Okay, dynamic on a stream kind of thing you can use it, but unless you have a dynamic kind of module plug-in, you cannot do it. So for a fixed stream, you can just give a subtitling and going on. Suddenly you want to change the kind of like the way the language switch over. So immediately say one side, the same person is viewing as an English kind of translation. The same person, the other side is viewing as a kind of Chinese translation, Japanese translation, or some other kind of translation. Those kind of things are all done by dynamic links. Those are kind of like streams done by streams module, which is dynamically going on different direction, and based on time they can. So you might have a morning lecture on English and the evening lecture on some other kind of language. Those kind of things are all very difficult, and these are called dynamic clusters. And those kind of things of learning as a dynamic kind of configuration, new algorithms coming in, new kind of configurations coming in, and new kind of modulation and demodulation methods. You can have two kinds of modulation: amplitude modulation and for frequency modulation. Frequency modulation is usually done kind of like on the same kind of frequency. Okay, it interfacing two frequencies on the same line. Okay, that is the kind of frequency modulation. So one is right angle to the other, and you can just modulate it. Amplitude modulation is a kind of another kind of thing where if the amplitude is increased, that is just both the things are like right angles to each other. Okay, amplitude modulation and frequency modulation. So these things you have to know. Okay, for dynamically it happens. Okay, that is why you have dynamic real-time systems. Okay, dynamic real-time something like that. Okay, where you can do frequency modulation, amplitude modulation is a kind of like a non-real-time kind of learning method, and for frequency modulation kind of is a kind of real-time learning method. Real-time learning method, since algorithms change every second, and sometimes it is quite dynamic, sometimes it is those algorithms come on the run and suddenly they vanish, and new kinds of algorithms come in, new kinds of algorithms go. There are fixed structure is not there. That is what dynamic is all about. Okay, these things are doing. So you just at that particular time a specific a cluster of algorithms is used, and that algorithm is used for at that particular time only, and after the next second it might be another cluster of structure which is using, that is called frequency dynamism or frequency modulated kind of waveforms. Okay, that is why it is called real time kind of artificial intelligence. So you have to know there are two kinds of AI learning. One is frequency modulated AI learning, on another one is amplitude modulated AI. Both are just perpendicular to each other. Some are faster, some are slower. So because it's something's dynamically changing, those, so that is why it is called frequency modulation, and that kind of modulation is done on an operating system kind of the learning algorithms. Those are called, real time artificial intelligence, because those kind of things are a little bit different. They are not well kind of like pattern recognition. You say something is running, you pattern recognition has to take a snap photograph or something like that through the eye, and suddenly 5 seconds later that same thing is that the object has moved to some other place, and it's supposed to predict that object in that place depending on kind of movement, and then immediately say that okay, if the object is moving, then I have to get ahead about 30 seconds faster than that object moving, and then you have to stop the object, those kind of things. Okay, so something is moving, say so how you had to, first it has to recognize the pattern, and then after recognizing the pattern, it's dynamically able to recognize this pattern. Pattern recognition itself should be dynamic, because the video is running and the sensor is running, and the sensor dynamically has to link those kind of patterns and then immediately come up with a new kind of solutions, because the patterns always is not the same. Okay, just the instant the pattern is one, the next instant there might be another kind of pattern, those kind of things. So it has to learn for instant to instant level new kind of algorithms, and that kind of algorithms which are learned kind of things is called a dynamic artificial intelligence. Those are kind of things which are used usually for kind of quite time critical kind of stuff. Okay, time critical kind of planning, time critical kind of like parallel processing, time critical kind of like dynamically linking modules and things like that, and using streams to do all these things is a very difficult process. So stream head, I already told you how it can be done, how it can be assembled, and how it can be, so dynamically can also link those kinds of streams. Okay, streams can be linked dynamically also. So today we are going to see the all file converter. This is an all file converter which uses those kind of things. Okay, dynamically you can just do a conversion from one file to another file. Okay, these kind of things, these are fixed ones. Okay, this particular thing is just do a file conversion, which are kind of like modules which get plugged in, and immediately you can just convert from one file to a text file to a Word file to a PDF file to a graphics file to a kind of voice file and things like that. So these are all file converters which does all the things. Now some of the things for encryption, other things over the network and all, some of the standard text is actually converted into some kind of graphics kind of interface. Sometimes it might be a video interface which is converted and then sent down the stream, and after that you have the word document is decrypted on the other end, and then the word document is got. So this kind of encryption, decryption, conversion, and all these things are used for some of the security purposes and other things. Those kind of things are all involved. So first thing you have to know what is the converter. Converter is basically a plug-in module which converts from one kind of things to another things. These are all file converters, and we can do it. Now I don't want to install and all the things, but I wanted to just show you some of the things, what are the things used. Okay, this is the kind of things that is convert to docx, flash, HTML, ODT, PDF, PTT, RTF, and things like that. Okay, you can do any kind of conversion also. Now there are other kinds of things which is AVI and FEI. AVI file is audio video interleaving kind of. So if you want to have different kinds of format, 3GP format to AVI format. AVI is nothing but audio video interleaving. Audio and video is put together and it's interleaved. So text files also can be converted into an audio video file, and after that audio video decrypted and converted into text file back again. So these conversions are possible because for this you want to just do some kind of encryption or something like that, then you can do it. Sometimes some files are easily convertible, like a 3 GB file can be converted into an AVI file or FLP file or something like that. So that is some kind of minimal kind of conversion where voice and
Data is used to convert. Now you can use text also converted into voice. Okay, text can be converted into voice, and those kind of things can be used. Well, just for encryption over the network and this kind of thing. Okay. So if you have a huge number of text files, okay, you can just convert the whole file into a voice signal, and send it down the line to the other end, and then you can decrypt the whole voice back again, normal text form from the other end, text form, and then you can just transfer the file. Okay, file transfer doesn't have to be the same kind of format going to the other end. Data might be used heavily, from voice. If it's a 200 baht rate, voice can be sent, which is easier because the whole thing is converted to voice, so you don't have to worry. It can be just got another rate. So those kind of conversion and other things can be used dynamically, how to learn the things, and for encryption and other things. So this is just an example of how the things go. Kind of like what is a JPEG and how different kinds of BMP, JPEG. These are all conversion formats. But I just wanted to show you how those kind of things. There are so many kind of conversion just for encryption and other things they use it. Those kind of file conversion on the dynamic link libraries are used for just for that, kind of like how we can do structural learning. So because some of the things we have to, for security purposes or other things, like you have to convert it to a different form and send it down the link for an immediate response to the other end. And sometimes projects has to be done from the learning methods have been done. Planning itself has got so much of things. Then project itself has got so many things. Okay, if you want to extend the project kind of thing, and those kind of things are done by artificial intelligence in a different kind of learning methods. Okay, so this is the dynamic learning method, which is called a real-time artificial intelligence kind of network. Okay, so today we saw what is a dynamic link. Dynamic link libraries or libraries which get connected to on the run. Okay, those are called dynamic link libraries. Streams the kind of modulation which you can do. Streams is another kind of things which is equivalent to dynamic link libraries, but it's got different kinds of things. Then you can use scripts to do that. Non-scripts on the fly you can create scripts and do the learning. Those are real-time dynamic scripts generated on the fly, and they real kind of logic generated on the fly. Those are called the frequency modulated kind of something to do like similar to frequency modulated and amplitude modulation when you are learning certain things. Okay, these are the kinds of things, because most of the world is a real time kind of thing. So you have to know these two concepts of what is dynamic learning algorithms and what is non-dynamic learning algorithms and other things. Okay, these are for just for pattern recognition. Pattern recognition itself uses non-dynamic algorithms and dynamic algorithms. A non-dynamic algorithms, if you show something like a bucket or something like that, and you have different versions of a bucket, and it learns all the things and different kinds of bucket. But if the bucket is moving kind of thing, then it's got dynamic learning. Okay, on the move it's able to recognize certain things on the video or something like that. Those kind of things are dynamic learning algorithms. Okay, dynamic learning algorithms always come into existence. Dynamic learning algorithms always come into existence for certain amount of period, or sometimes kind of for a particular amount of time, and then after that it vanishes. And sometimes it might be reused again, it might be regenerated again, sometimes it might be just going out of sync, and new kind of things, algorithms might come in. These are called dynamic kind of learning algorithms and other things. They are used in pattern recognition, deep learning, and even for machine learning kind of, but they are mostly not used for kind of a fixed kind of like a robo or something like that, a manufacturing robo and other things, because though there it is very difficult to control those things. Okay, so you got that because it is learning new things in a different form, faster form and things like that. It's quite, but if it is structured form, usually they learn things easily within a particular quite a spectrum. They can use it. So it's a kind of like within a spectrum you can do create things, dynamic ordinary learning kind of methods. Okay, it's just the environment, same environment is there, it is okay. But if it is kind of new kind of environment, all the things have to be learned again. This is a sort of dynamic switchover. So that is called a dynamic artificial intelligence. So today we wanted to see what is a dynamic algorithm, what is the thing, what is the difference between time related, non-time related kind of learning, and how it is used in pattern recognition and other kind of structural formations and machine learning and other things. Okay, thanks for now. That's all for today.